So today we're going to do a short video on cut rifling. This is rifling that's going to be used on muzzle-loading rifle barrels. It's single point cut rather than being button rifled or broached or hammer forged rifling. There are many techniques, but this video is going to cover single point cut rifling, which is traditional for muzzle-loading rifle barrels. We've started doing this just recently, started developing the process, and it seems to be working pretty well. It's something that we had to develop on our own. We didn't really have any real guidance from anybody other than what we could find on the internet, but it does seem to be working pretty well, and just thought we'd show what the process is. It might be nice to share it. We usually don't share too much of our processes, our machining processes, but rifling really isn't our bread and butter here, so we thought it'd be, as a kind of a change, it'd be nice to show how we're accomplishing it. So the reason we're doing some rifling is barrel blanks that are 40 caliber and below, when they're provided to us, are unrifled. That's just the manufacturer's choice. They prefer not to rifle anything 40 and below, so we've decided that we would figure out a way to do it here in our shop. We're performing this task on a HAAS TL2, so it's a CNC lathe is what it is, not any kind of a dedicated rifling machine, just a standard HAAS TL2 lathe. And when we bought the machine, I had in mind that we could probably use it to rifle barrels. Although some people had their doubts, but it's actually been working pretty well. It was a pretty big process to figure it out, how to accomplish it, but it seems to be going okay. So with all that said, load up a part and we'll kind of talk our way through the process. So there's a barrel in the machine right now that's finished. We'll pull it out of the machine here and load another barrel. So that barrel extends through the headstock of the lathe and extends out. It's supported on the back end with a cat's paw, I think is what that's often called. We use a lot of dark, high sulfur cutting oil in the process because it works very well. In this case, the barrels are rifled with 6 grooves, and they're about 10 or 11 thousandths in depth. We could certainly go deeper, but I don't think there's any need to go any deeper than that. I think it's just a wasted effort anywhere above 10 thousandths. So I'm going to start pulling this apart, maybe talk a little bit as I take it apart. This silver piece on the end of the barrel is a mechanism for indexing the cutter. So with cut rifling, you're taking a pretty small amount with each pass, and then the cutter gets indexed to a more stick out from the body of the tool. And the silver piece that attaches to the barrel is what allows for the indexing of the cutter. And I'll probably go into more detail about that here in a few minutes. Typically on most rifling operations, people would use a separate mechanism to index the cutter, but since we have control of the axis of the lathe, the C axis, we're able to use it to not only turn the barrel as the cutter is withdrawn, but also to adjust the cutter. This is something we came up with that's kind of clever, I think, and has worked pretty well. So we'll go ahead and start tearing this down. Let's see how this slides off. And it has a little bird's mouth sort of shape to it, and that's used in the cutter adjustment. Okay, so I'm going to withdraw the cutter. Okay. So yeah, we'll go ahead and load another barrel onto the machine, and maybe at the end, after it's complete, we'll look through the bore, see the rifling, and see what it looks like. Okay, since the barrel's been removed, you can see the cutter a little better. And it's really not too complicated once you kind of get the feel of things. This is the cutting edge. Each cut, each pass through the barrel, we're taking approximately maybe 4/10, about somewhere around 4/10, a little less, 3.5 to 4/10 per pass. Now it's interesting that most everything I read talked about taking 1 to 2/10 per pass with cut rifling, but we've had much better luck taking a heavier pass, and rather than actually getting just kind of powdery metal from each pass, we're actually getting a chip, and we're still getting a good bore finish, rifling bottom of the rifling groove finish. So I think it's worked very well for us, and it decreases cycle time a lot because this is a time-consuming process. So the way the cutter advances is you turn this adjustment screw in the back, which drives a wedge underneath the cutter and raises it so it protrudes from the body of the cutter. So we'll go to maybe like the full out position. You can see it raising up. So here we can probably see the cutter is now sticking up a little bit above the body of the rifling head. And the area in front of the cutter is a pocket that contains the chips. And this needs to be large enough that the chips don't become packed in that area, or else it'll cause a lot of bad things to happen. In the future, I might even make a cutter body that has even more chip clearance or area for the chip. This is working okay, but I think we could probably take bigger cuts, decrease cycle time if we have a little more chip clearance. One thing that I'll note is the cutter can slide backwards, okay? It's spring loaded. So the purpose of that is as the cutter is pushed back through the barrel, it can withdraw. That means that it'll have less projection from the body of the rifling head, and it won't put a lot of strain on the components, all the components. It'll slide back through the barrel easier without wearing the tip of your rifling cutter out or binding, less chances of it binding in any way. So that's the key part of the design of this cutter. So this cutter is attached to another rod, and again it's pulled through the barrel. This rod is hollow. Pressurized oil is forced through the rod, through the cutter body, and it will actually come out the cutter itself, which is important to keep it lubricated during the cutting process. So I think what we'll do now is I'll take you in the office for a moment, and we'll show a little bit about the design of the rifling head. So we originally started this rifling process using a cutter made by another company, but it had problems. We didn't have very good success with it. Had problems with the cutter breaking. And I think it's largely due to the cutter design being more appropriate for modern firearms. There wasn't a very big pocket for chips. And you know, with shorter barrels, you probably wouldn't need that larger pocket. Our barrels are 44 inches long, so that increases the quantity of chips with each pass. So that was one problem. I thought it was kind of weakly constructed. So our goal was, when we redesigned it, was to try to make the cutter as robust as possible. A nice, clean, robust design. So we've designed this in Cad software. This happens to be Fusion 360. I can kind of give you a quick tour of it. First, I'm just going to rotate it a little bit. So if you recall, it's pretty similar to the actual cutter that you saw out on the machine. And this is the pocket. This is the cutting edge right here, the adjustment screw. It would be attached to the rod right here is where it would be attached. Okay, now we'll show a section view of it. We can get to the details a little more. So if you're really interested in this stuff, you can pause it and look at it in a little more detail. Of course, this is the body of the cutter. This, let me turn it here. This is the body of the cutter. The actual cutter itself is right here. The adjusting ramp or wedge would be right there. One key feature of this design is that the wedge is actually attached to the adjusting screw. That way, when you turn the screw out, the wedge will follow it, as well as pushing the wedge in. And that, from what I understand, sometimes the wedge can tend to follow the cutter if it's pushed inward when the rifling cutter is pushed back through the barrel, and that could be a bad thing. So this is just a more sound, robust design to have the adjusting screw attached directly to the wedge, so it locks it in place. So as this wedge moves forward, the cutter then raises upward. It pivots on this mechanism back here, which is simply a ball, or it's a ball bearing with a hole through it. You can see here. Let's go and turn that off. You might be able to see a little better. It's a spherical ball right here, and that pivots in this hole. Now, one thing that's not shown on this is there's a coil spring back here that applies pressure to the cutter to keep it forward during operation. One important design that we tried to focus on is to fix the cutter position while it's in a cut as strongly as possible. So this V, this angle, and this angle is very important, because as load is applied to the cutting edge, it forces it back into this V, into this corner, and very strongly holds it in position, which is a really key design. So we tried to keep this as simple as possible, but as robust as possible, and it's worked pretty well. Okay, we'll go back out to the machine. So this is a barrel blank ready to be rifled. This blank was produced by Green Mountain Rifle Barrels. So it's been bored, reamed, and honed. And it's, like I said, ready for rifling. So we're going to install it in the machine, get the machine set up, and then demonstrate the rifling process. A little bit of a challenge is to position the barrel correctly. The breech of the barrel, which is nearest the chuck, is where the gun drilling operation began. So the hole is on center, very, very close to being on center. At the muzzle end or the opposite end, there's some run out of the bore relative to the OD. So we want to position this so the bore is on center. So that's what you'll see me doing here in the next few steps. So what we're doing here is we have this outboard machine table fixed to the floor, and this tailstock is located such that it's pretty much on the lathe center line, or the lathe spindle center line. So we attach that. Now we have a center that we'll twist in the barrel, position it. So now the bore is running on the lathe center, the center line of the lathe. We're going to come back and tighten up the chuck good and hard. Make sure our center is engaged well. Now we can turn in our cat's paw. Sews in. Okay, so that is now fixed, so we can remove this tailstock. This is a little bit tedious, but it's really not too bad once you get used to it. We may find a little easier way here at some point, but it's working okay for now. Now we're going to jog the machine to push the cutter back out the barrel. The next step, we're going to set the cutter for the initial depth of cut. So these are 40 caliber barrels, so we're going to be looking right at about 400 thousandths for the cutter position. So we're going to use a micrometer and see where we're at. Okay, so we're a little under. So we're about a half thousandths under there. We'll see if I can see what another half turn will do. Probably is too much, but we'll see. Yeah. Well, we're going to go ahead and start right there. This says 401, but there is some force down on the cutter. So I found if I'm about a thousandths over bore diameter, it still starts the cut pretty well. So I don't think there'll be any problem with that being too high to start with. I don't believe so. Okay, so the cutter is now in position. Make sure my spindle is oriented properly. Okay, we'll slide on the adjustment mechanism. So this just affixes to the barrel itself, which is kind of unique. It's I've never seen anything like this done by anybody, but it works. So what it does is this allows us to use our spindle, our C-axis, to rotate this adjustment mechanism, which will in turn adjust the cutter. So I'm going to hold that on with a couple cap screws, get it in position. Okay. So what I like to do is that, go through and do a kind of a check to make sure I've not missed anything, because things can go bad with a setup like this. You have to pay attention to details. So the first thing I'm going to do is just make sure that my spindle is oriented properly where it needs to start. It is. We've tightened the chuck tight. We've tightened this cat's paw tight. Our adjustment mechanism is on. Our cutter's been adjusted. So I think we're pretty much ready to go. We're at the right starting position. We're going to turn on the coolant, which is the pressurized oil. So I'm going to plug that in. We're going to make that an automatic feature here at some point, so the oil will come on with the machine. You can see it start to drip, and if we come over here to the end of the barrel, you'll see it running out. And that is primarily from the oil running through the cutter itself, the cutter rod and the cutter body. Okay, as far as the programming goes, I won't go into a lot of detail about it. It was a little bit tricky. There are some details to try to make a CNC lathe function like this. It's it's not an easy thing. We've written the program in macro form, so it just repeats these steps. We can easily change a few variables, like how far the cutter's indexed each time, how many passes can be easily changed, just as a macro variable. So we're going to let that oil purge a little bit. It's got a little air in the line, but we'll let that purge and then we'll get going here. Okay, we're ready to start this, so cycle start, and one more cycle start. So we have this set up so there's an air blast at the end of each cycle to blow out the chips from the cutter body. The rifling head is being drawn through at about 350 inches per minute, which happens to be the maximum feed rate of this lathe. I'd like to speed that up a little bit. I could do it perhaps with a rapid move, which could be, I believe, 450 inches per minute. But I'm not quite sure. It'll take some work to try to sort that out. There's a total of 32 passes per groove with 6 grooves. So it cuts each of the 6 grooves and then adjusts the cutter. So each groove has 32 passes through it, and it gets 10-11 thousandths in depth when it's complete. So each pass is somewhere just a little below 4/10 of an inch. That's 4/10 of a thousandth. 0.0004, a little less than that. So when it first starts cutting, the chips are a little bit, a little bit in pieces, a little powdery, but then as it gets engaged a little bit more, it'll take a full cut. So in this case, it's adjusting the cutter head right now. So one thing that's been interesting with this project, like I mentioned, we really didn't have anybody to guide us through the process or help us along. It's just what we could pick up from basically reading online. And it's pretty remarkable that you can learn so much online these days. Now, with that said, we may be doing some things that aren't conventional, or there might be better ways. So if anybody has experience with this, feel free to let us know your thoughts. Total cycle time is just a little over an hour right now for the whole barrel. We would like to speed that up. I have some ideas of how to accomplish it, but we'll see. Right now it's a pretty stable process, a reliable process, so that's why we're pretty happy with where it is at the moment. Now when we look at the end of the barrel, we should see just the start of some rifling grooves now. And you'll be able to see here when this rifling cutter comes out the end of the barrel, it's going to be adjusted at this point. Pretty clever. Chips are still a little bit kind of fragmented, but here after it adjusts a time or two more, we'll start getting a little more of a complete chip. We're using a carbide cutter, or actually it's a carbide tipped cutter. We've made all the components to the rifling head here in our shop. At one point we kind of explored buying a dedicated rifling machine, but they're extraordinarily expensive, and it's really not that complicated what you're asking the machine to do, and we thought we could very likely use this lathe that we also use for other operations on barrels. It's a bit messy with the oil blowing around. In operation, we keep the doors shut here, and it contains all the cutting oil pretty well. So now we're on pass 25 of 32. Kind of take a look at the nature of the chips here. One thing we found is the importance to have the cutter very, very sharp to get a consistent chip. So about every 2 barrels I touch up the cutter. And then if we look at the other end, we'll be able to see that the grooves are established a little more. Cutting oil causes a little distortion in how they look, but you can probably see that they're becoming a little more prevalent or prominent. So we'll let this run for a while, and when it's about done, we'll bring you back, show you the last few passes. We'll pull the barrel off and we'll take a look at it. Hold on, I'll be back. Hey Mason. Hey Mason, can you watch Henry a little bit now? Yeah, I'll get those, I'll pause them. We're gonna have Mason come in and watch you. There you go, feel free to have a seat and relax. Say hi, Mason. I want to show another view down here. It's a very neat view. So it's taking a little more of a full chip now. Only 8 passes to go per groove. Here's a little bit more of a close-up of the chips. They kind of accordion up, but I believe that's probably the full-length 44-inch chip. It's been compressed somewhat and then accordions it. So it condenses it. It's probably when it was cut, it's only 3 to 4/10 thick. And we'll bring you back when it's complete. Shouldn't be too long here. And then we'll pull the barrel off and inspect it. So some of you that have seen previous videos have seen our little dog here. We actually call her little dog. She's a shop dog, although she goes over to the house at night with us. But she's not doing so well. She's getting older. She's about 14 or so. She has some problems with her eye, which is, we've had her to several vets, and it seems as though she might have some kind of an autoimmune disease. So she's not doing so well, but she's not in too much pain. She's just being a little bit shy and a little scared right now. So she's still doing okay, but she probably doesn't have too many days left. But she still likes to eat. One of our employees brings dog treats for her, and she constantly begs for the dog treats. I think that's most of her diet these days is dog treats. One more pass for each groove, and then it'll be complete. So the cycle is complete. So now we'll remove the barrel, we'll clean out the inside a little bit, wipe it out, and then we'll try to get some little bit of footage on how it looks on the inside, some images of the inside of the barrel. I found it really helps the bore a lot when we run some Scotch-Brite through it. So we've been doing that on all the barrels. Tends to polish it down. Kind of see the little bit of polishing comes off with it. We'll run a nice clean patch through it to clean it out, and then we'll get try to get a look down it. I like to get a nice snug fitting one there because it pops that and cleans that really good. Okay, so I've run a couple cleaning patches through the barrel, and I've run some Scotch-Brite through the barrel. That tends to smooth things up a little bit if there's any kind of little burr or irregularity, which I haven't seen. It would tend to eliminate it. It just tends to clean it up a little better and polishes it out a little bit. We'll try to hold this up somehow that you can get a view down the barrel. Maybe I can put it here and we can look towards the window. So the grooves are about, I'd say, without measuring them, they look to be about 10 thousandths to 11 thousandths deep, somewhere in that range. Well, this will wrap up this video. If you have any questions or comments, please let us know. Like I mentioned earlier, that we're new to this rifling business, so if you have experience and have anything to add, then we'd love to hear from you. So thanks for watching along.